Right. Thank you for coming back at nice and on time. It's nice to see you all back again. Hope you enjoyed a coffee and a cheeky cookie, which was really good. So just moving on to our next session. So I'd like to introduce. Sorry. Thank you. Andrew. I'm so stylish. It's beyond belief. Okay, yeah. So I'd like to introduce Andrew Quinton from BT, who's going to talk about AI computer vision for health, safety, and security. I dare say, like myself, you probably saw the stuff on social media yesterday about this amazing sort of computer vision application that people have built to make people look like as if they were born as synchronic characters, and it turned a rather nice lady into a rather bored-looking man. So there's a bit of work to be done on the technology. Anyway, if in terms of the way that the session's set up, if anybody have any questions, if we do have time at the end, we can go for it. But there's a handy dandy QR code, which takes you to a web page which allows you to put questions in place. And we have a session at the end of this particular block where we can answer any questions that people have. If they miss this from this particular thing, then at the beginning of the panel session at the end, this will come up again, and you can submit different questions for different sessions. Okay, well, enough about me. And also, if people looking at social media, say hashtag comment 2024, go and spread the word. And say, this like to introduce Andrew with his talk. Thank you.
Thank you. So Andrew is following me in the next slot. We all thought there was going to be a lectern here to read our speaker's notes. So unfortunately, there isn't. So I haven't got my notes. So apologies if I sort of go back and think of something really useful halfway through the presentation, but we'll see how we get on. When I saw the slot at 11:30, I thought, oh no, I am the one between you and lunch. But I actually think lunch is a little bit later on. So hopefully we're not all getting too hungry just yet. But I am here to talk a little bit around computer vision and AI. Brief introduction on me, Andrew Quinton. I've been in the industry, what did you say in there, 20, 25 years in the technology industry. I've done various roles from portfolio development in the labs right through to the director of our global design team. Today, though, I'm very, very nicely called a principal architect in 5G and IoT solutions at BT. What I tend to do is I look at 5G, IoT, and emerging technologies, including AI and computer vision, and look at how we can make these technologies and solutions work for customers today. So I'm not looking at 5-year out kind of stuff, which the boffins do. I kind of look at the tech and how it is here right now. And as you saw from the first slot on AI, fantastic slot there introducing the pace of everything. AI has been around for a long time, and indeed computer vision has as well. Alongside that, I also speak to students and future technology leaders as I am an associate lecturer down at the University of Exeter as well. So talking about digital transformation. There's a QR code on there. It's not at the end, so if you do want to capture it, please do now. But very happy to talk on LinkedIn, get your thoughts. Very happy to give you some thoughts on what I'm about to talk about now after the session. No one's got the camera out, so I'm okay. So we've heard a lot about AI, and I'm actually going to introduce a new word into it, which is responsible AI. Okay, so responsible AI is here to help. It's not just about spying. Okay, now when I talk about responsible AI, I'm talking about using the solutions, using the technology to provide meaningful information to a human, to a real person, to make a better decision. Okay, I'm not talking about AI doing its own thing, making its own decision. I'm not talking about AI learning itself, because some AI does. Some AI can learn on the fly, but what I've seen and what is possible is you can start to introduce bias, you can start to introduce scope creep, and the potential for misuse grows. With a rules engine, you're making sure that the rules engine is making the AI usable. So it's not creating lots and lots of what we call false positives and showing things that aren't actually a problem. Now, AI does make people nervous. When you start talking about surveillance and cameras, it makes people even more nervous. Snooping, spying, tracking. These are all very emotive words that can be associated, and people do associate with computer vision technology in general. If you walk around any city centre, how many cameras are looking at you at any given time? And I think with responsible AI, we're looking at tracking people and objects, but we're not interested in their identities. And that is a sort of quite a solid line when it comes to computer vision. Spotting somebody, spotting a car, spotting an object, but linking that to an identity, an individual, that is a line that we try not to cross. But what is clear that computer vision does have a lot of potential in the construction industry. Okay, you can unlock new insights on a project site in an area. You can improve efficiencies. You can draw out waste, as well as some of the other things that I want to talk about in health and safety and security. And those themes, you know, I've spoken to a number of customers, a number of people who operate in this industry today, and they tell me that these are some, not all, but some of the challenges that are faced right now. I mean, I don't know if they resonate with anyone in the room here. Yeah, I mean, health and safety is a really important one. This industry, more than any industry, I think, can have the potential to really seriously harm people if things go wrong. So absolute best-in-class health and safety is really important. Site security, and that's not just about the perimeter, it's not just about keeping unwanted folks out, it's about what goes on inside the site as well. What security during the day, during the night can be provided. Site compliance, whether it's local rules or wider regulation and how they're being followed, but also operational insight, the opportunity to take new forms of data and learn stuff from it is an opportunity that we should all take. And quite often, a lot of sites have cameras around the site that could be doing all of these things. For that, what is computer vision? Now, we've had an introductory talk earlier. It is a field of AI, of course, that's why I'm here. If you think AI allows computers to think, computer vision allows them to see. And so you can take real-time video or recorded video, and you can run real-time advanced video analytics over the top of it. It's looking for things, it's producing metadata, it randomizes, anonymizes the video data. And what that gives you is, well, you can do one or perhaps all of the top 4 items here. So looking at live alarms, this is where the AI has been told to spot something that's wrong and alert somebody accordingly. And the simple rules are, is somebody climbing over your fence at 2 a.m.? Has somebody wandered onto your site not wearing a hard hat? Now, they're the kind of simple, obvious rules, alerts that you can put into place. But then you can start to combine the cameras, combine the rules, combine the situational awareness. So one use case I heard about is quite important for one customer is there's hazardous areas, and people walking into those areas by and large on their own is not necessarily a problem. But if another camera is spotting a vehicle which is about to encroach and reverse into that space, on another camera, person in hazard zone, vehicle about to reverse in, those 2 separate rules might actually trigger an alert. And that alert could be a message, but I mean, that person in that area probably is not going to get it. So it could be flashing lights, it could be a PA system, could even be a haptic device that they're wearing just to alert them that there's some sort of danger, something about to happen. But live alarms is there to spot things on your behalf. Now, reporting, this is taking the data almost like post-event, after the event. And one that I always talk about here is let's say it's 2 a.m., police have phoned, someone's broke into site and they need your help. And what they need to do is they need to understand, well, where have they been? What potentially have they encroached upon? And actually, are they still on site? Is there still a danger? Is there still a problem? And not just in construction, but many in industry, I've heard stories of people sat with the police, looking over their shoulder, looking at 10 different monitors with a finger on the fast forward button, trying to find somebody, trying to find the assailant. And with computer vision, what you can do is you can spot them anywhere at any given time, and then you can tell the AI, can you tell me where that person has been instantly? And it will then produce an instant map across all the streams where they've been and potentially where they are now and potentially where they're hiding. Completely different industry, but one use case I always talk about with this is computer vision was deployed across all of the cities, all of the transport interchanges, all of the stadiums during the FIFA World Cup in Qatar. And it was finding lost children in about 4 minutes across the whole city and transport infrastructure, because the last instruction was, well, where did you last see them? What were they wearing? And the system can find exactly where they are. Notice I haven't used the word facial recognition. I can potentially come onto that another time. And so that's really the live search forensic capabilities. But the final one on here is third-party output. And this is where you can integrate the computer vision into different systems. You can export the data into what we talked about earlier, digital twins. There's a project I'm aware of on the South Coast, not far from here, where we're actually exporting data from computer vision into a digital twin to look at traffic analysis. But the other areas is you can link it into card readers. I mean, most organizations will have some sort of card reader or a PIN machine to get on off-site, in and out of buildings. And what you can do is you can compare that system with computer vision to spot things like tailgating. So, for example, has one person entered their PIN or swiped their card, the vision has spotted two people enter. And that can generate an alert and say, well, I've only seen one swipe, but two people enter. There's a tailgating incident happening right there. But third-party output can be linked into a number of different systems. Another example I've seen is where the ANPR data, so when trucks and vehicles arrive, the ANPR is taken and they're automatically routed to where they need to be on site using a combination of digital signage. So the barrier can automatically open and automatically send them or tell them to go away and come back in 3 hours' time. But that whole routing and tracking and understanding vehicles and where they are and when they've arrived is really, really important, because when a vehicle's arrived and told to go over into the corner, potentially people can be told that the vehicle is now on site, en route, and be ready to unload. And it's small gains in those areas that can really start to improve in efficiency on a given site. So again, thinking about some of those challenges, some of the top level benefits that I kind of recorded from those conversations. Again, by using those RTSP video streams, just basic video streams, normal video, you can create metadata to accomplish some of the things on screen. So reduce high cost incidents. You can start to spot problems before they become big issues, before they interrupt your flow of operation. You can help monitor health and safety guidelines. I mean, the PPE is a really good one. One area I'll cover in a second or two is the visual inspection, because actually, as well as spotting people and objects on a site, you can use computer vision to do quality inspection. So you can look at deep analysis of objects as they're moving to spot if there's problems, are they cracks, are they dents. And again, the example I always use, it's not quite construction, but it's still making stuff. There's an aircraft manufacturing company. And they use this system to detect the quality of the rivets into the aircraft body. And the system is trained to say, well, if a good aircraft rivet looks like this, if it doesn't look like that, then tell us. And I used to use that use case an awful lot, but now I kind of have to say it's not Boeing. Because, they have missing bolts and all sorts of things. So no, it's the other one. But, for me, if a system is looking at aircraft rivets, and telling it if it's okay or not, that's a high degree of accuracy and a high degree of trust in the AI and the sort of things it can do. It can do the operational efficiency piece, so you can optimize your site and your layout. So if you've got people in heat maps working in one part of the site, and you've got equipment or raw materials in another part of the site, actually, are you planning where things are moving around accordingly? Is it in line with your project plan and where you should be at that given time? And you can also look at things like completed production cycles to accelerate turnaround. You can use AI and you can use the system to say, well, actually, is the build, how far have you got on the project? Is it where it needs to be in to your project plan? Has that particular building, the wall, the roof, the elements, the windows, the utilities, have they been installed? Are they to the level it needs to be compared to the project plan? Is there slippage being introduced? Control room overhead. And again, I talk about the fast forward, looking at the screen. A person can only look at a handful of screens at a given time. There is a scientific study that's been done on how many screens a person can look at any given time and actually take meaningful data from it. I can't recall what it is. But if you've got 15, 20, 30, 100 cameras looking at all sorts of different things, people can't look at those all concurrently. So using computer vision allows that extra pair of eyes, that extra pair of view, to actually provide that meaningful insight and point the person to where they might need to look next. And finally, safety and security, perimeter protection, and all that sort of good stuff. I've got some videos at the end, which I'll show, and hopefully we'll get through to them, which starts to bring it to life a little bit more. Now, I've talked a lot about use cases, and I'm going to show you some examples of use cases after this, but they tend to fall into one of these 5 key themes, okay? There's probably a 6th one that's going to come, and I've not thought about it. But the optimized operations piece, again, looking at an organization, looking at a site, looking at where the people flows are, you can start to understand and start to eke out meaningful information from that. The workplace safety, this is the sort of does what it says on the tin kind of approach. But again, looking at where you've got people, where you've got objects, if the PPE is not right, if people have tripped up and fallen over. There's lone worker protection. So if you've got security on site overnight and they've not been spotted for a while, are they injured? Are they fallen down a hole? Again, it's looking at how you can perform that workplace safety function, but a little bit more intelligently. And visual inspection, as I say, that's a really important, that's a really neat one. Looking at objects, looking at materials, looking at things as they're coming in and out. So it doesn't have to be stationary. You know, things are moving in and out all the time. You can use drone footage to look at the top. Are things looking the way they should be using the AI and the artificial intelligence? Enhanced security. Talked a bit about people climbing over the fence and all that sort of thing. It can do object detection, so can it spot weapons and things such as that? And absolutely, yes, it can. But it can also spot suspicious behavior. So as the loitering, people hanging around in areas they shouldn't be. God forbid, it can also spot things like aggression detection and fights. Hopefully we don't see too many fights and whatnot on project sites, but again, they can happen. Yeah. And finally, the digital signage and integration. So I talked about ANPR. I talked about information totems. I talked about integrating into the barriers. You know, there's some of the examples. The ERP systems, the project management systems, the digital twins, all of the data that comes out of that analysis is turned into randomized metadata and can be exported into a number of different systems. Anonymously as well, I might add. So when it comes to AI, you might be thinking, cool, you know, how long does this take? Is this a big job? Well, these are some of the example use cases about computer vision. Now, I talk about these being out of the box. These are sort of very common use cases that we see across different industries, whether it's looking at ANPR, forensic search, shipment tracking, whether it's talking about project progress reporting, wrong way detection, quality inspector. These are all things that can be done fairly quickly out of the box. When I say quickly, you can enable computer vision on a site within about 2 hours. That's kind of the speed of which you can go. A lot of the AI systems, a lot of the computer vision solutions are no code solutions. They're very GUI based. You can set up a number of different rules. Any one camera can be looking at multiple things all at the same time. You know, we've enabled sites, we've enabled city centers within just a few hours, looking at 30, 40 different rules, all concurrently, all together at the same time. So computer vision is not a complicated thing to do and deploy. The system that BT uses is pretty camera agnostic. We use a system that can operate on 30-year-old analog cameras and VHS video recorders. And yes, there is a customer we've encountered that are doing that. But the other thing it can do is it can be trained, and you know this was talked about earlier on. The AI can be trained to look for things as well. It can look for liveried vehicles. It can look for uniforms to exclude those people potentially from alerts and alarms. But it can look for anything. The simple rule with AI and computer vision is if a camera can see it, it can be trained to do something about it. Okay, and they're the sort of simple guidelines and rules. So before I do the videos, and I keep promising the videos, a couple of quick examples. So this one here is a sort of material supply demo, builders merchants maybe. And in these environments, they're dynamic, they're fast moving, there's lots of people, there's lots of vehicles, there's lots of activity going on. And quite often it's being done unmonitored, unmanaged, people don't really know what's going on. You know, are the vehicles leaving with the items strapped on correctly? Are they complying with the regulations, laws, requirements for that, for example? These are all things that computer vision can help do. it can monitor those areas for their health and safety. Detecting falls, health and safety incidents. So again, I talk about lone worker protection. If you've got people walking around, if at the end of the day you're counting the number of people off of site, have you got the right number of people coming on and off? Are you missing anybody? Is somebody walking around at 2 a.m., security chap, and they've not been spotted for the last half hour? Does somebody need to send a text message to their phone to say, are you okay? Because you've not been spotted in a certain period of time. So detecting falls, health and safety incidents, you can use that to your advantage in these quite high flowing, high dynamic environments. And the last one, touched on it earlier with barriers and ANPR, but again, any particular project site can have vehicles coming on and off all the time. And sometimes they come early, sometimes they're late, sometimes the scheduling is all out of action. So a large site can have these hundreds of vehicles coming in each day. How can you better manage the flow? So you can look at the vehicles, you can identify the make, model, you can even identify who they are, where they come from, the delivered van, the trucks. And you could start to understand and start to schedule and link that into a bit of a pattern to bring in some levels of efficiency. And again, you can start to automate this with automatic barriers. You can start to put digital totems, as I said earlier, to talk about sending people to certain areas, or send them to a stacking area to say, look, we're not ready for you just yet. But again, these sort of vehicle areas and management is a particular area that computer vision can help. So I think these will work, hopefully. These are sort of example videos. I don't know, hopefully this will bring it to life. I don't know about you guys, but when I was at school and the teacher always brought in the TV to listen to a video, it was always like the best bit at the end. So hopefully this starts to make it a little bit more real for you guys. But the first one's proximity detection. Now this is people. This was probably used about, what, 3 years ago? Was it 3 years ago? When social distancing was really important. But the example here is proximity detection can be used for anything. It can be used for vehicles, it can be used for objects. If two things are getting too close together, can you detect that and put an alarm on? And hopefully for the eagle-eyed amongst you, you can see the bounding boxes that appear across each of the video. Next one, smoke detection. Smoke detection indoors, not a problem, because usually we've got smoke alarms everywhere, but detecting smoke outside is more of an issue. One of the neat use cases that I've seen for this is actually used at EV charging stations. So if the actual charging station's starting to emit a little bit of smoke, the whole battery vehicle side of things, that's bad. And that, something needs to happen really quite quickly in that space. Trip and fall. So this chap, unfortunately, is about to incur an accident. Oh, down he goes. But luckily he gets up. Now, the system here will say, well, he got up and then all things are green again. And he's probably styled it out pretty well. But actually, if he stayed down, maybe that's a different type of alert. Somebody needs assistance, somebody needs support. This next one, it's a dummy. I didn't tell people that once and they were a little bit alarmed. But the fallout height and gantry, again, the dummy falls down and an alert is indicated at any one time. And if you think of all these rules running on cameras, you can have all of these running concurrently at any given time. The next one's PPE detection. This is a railway station example. Does anyone know the railway station? Can anyone see the sign? No, London Bridge. But this system is deployed at London Bridge. So we work with Network Rail and there's a lot of areas around PP detection in this space. And the last one, this is an airport example, but again, any industry where you've got sterile zones, where you've got people that, shouldn't be walking, if you've got specific walkways that people should follow, people taking shortcuts, can you use this? These two chaps are having a time of their life, but then they're crossing over into the area that they shouldn't be. And again, speeding, going the wrong way, leaving their vehicles, all of these things can add up and cause problems. Security, so fence attack intrusion. Now, this is a kind of low light camera with not particularly great quality, but that's okay. Computer vision does not rely and does not need to rely on 4K, Ultra HD, brilliant cameras. It can use those 30-year-old analog cameras I talked about. But again, someone moving in, someone getting close, and this might be a thing at night time. In the daytime, that area is pretty busy. You don't need to alert people. The rules engine can say after a certain time, the AI kicks in and starts to look at a different example. And this one's the same, but in this example, it's a vehicle. Apologies, these vehicles were supposed to repeat and rotate. So if you don't spot them the first time, I can play them again. But this one here is dynamic zone monitoring. So someone's entered into a different zone, but in this case, it's a PTZ or a pan tilt zoom camera. And the AI can take the camera over and zoom in and start to understand what's going on. Again, to provide the operator with more information quickly and increasingly useful. Two-factor authentication. This is the elephant in the room. This is facial recognition. This is biometrics. But in this example, the user has got their biometric identity attached to their card that they scan. They're being identified and they're allowed to go through. And at BT, you know, we have a ethics and responsible AI and how we use facial recognition. There has to be very, very good use cases to deploy facial recognition. You can do it in this country, it's absolutely fine, but there needs to be very good use cases to deploy them. So high security areas, public safety, public health. You know, we don't want to be putting facial recognition onto the high street, for example. Secure zone tailgating. So this is, again, this could be any entrance to any site. Again, London Bridge, the chap, super helpful, leaves the door open for his colleague, but the system's detected someone gone through the door, but they've not swiped the card. So there's an intrusion, there's an alert accordingly. And the last one, apologies, the video got on for a little while, but this same gate in London Bridge, those two chaps have walked by. Another one enters the scene, and what will happen again for the eagle-eyed amongst you is a little timer will appear above their head, and it will start to count. And I think in this case, it'll be 30 seconds. And what it's saying there is after 30 seconds, that person's loitering. We deploy this for a stadium in London, one of the sort of big ones with a big archway. And again, in sort of 3 o'clock on a Saturday afternoon, when there's a game on, people hanging around loitering, not a problem. That's kind of normal. So the AI doesn't look at that. It's not interested. But someone hanging around at 2 a.m. on a Tuesday night, that's a different proposition. Can someone be spotted? And again, the same for any sort of environment and any project site. And then the last set of videos, really, for me, this is some of the monitoring. And again, this is the GPS tracking. So all the cameras can have geo positions on them. And you can start to identify where people are. And again, if you've got a big site, you might need to know where you need to send help, where to send support, whether it's medical, security, police, or otherwise. Abandoned vehicles. This is an airport in the Middle East. This is a good example of a rules engine. So what happens here is a car pulls up, not a problem. Driver gets out. Again, not a problem. Driver walks away from vehicle, that is a problem because he's now abandoned his vehicle. He's not helping a passenger. He's not doing anything like that. But that's an example of the rules engine stacking up to show actually there's a problem happening. Last few from me, I'll just start hitting play. Abandoned objects, again, from a security perspective, certain sites are probably needed to be more secure than others, depending on their location. So abandoned objects is an issue anywhere. Suspicious items, suspicious objects. This chap's about to do some dodgy running away. There he goes. But again, the rules engine will say, well, has that person put the bag down? Has that person walked away? Have they gone a certain distance? And that's the difference between just false alarms and someone actually dropping something off. The investigation, so this is your 2 a.m. scenario. You've found someone getting on site, you've spotted them, and now the AI is determining where it thinks. And that sort of bar across the side here with a probability rating across all the possible answers is giving that operator a view to say, well, I think it's that person. I agree with the probability. And it starts to map across a given site. And on here, heat maps and location dwell time. So again, this is using that historical data to start presenting heat maps on a given site, a given environment. This example is retail, so where people are walking around on a retail site. If you've got all your hot offers in one part of the site, but people tend to be dwelling in the other half of the site, maybe you need to move your promotional items to somewhere slightly different. And final one here, again, facial recognition. This is just to show that actually, even with facial masks and glasses, there's degrees of facial recognition that can be performed correctly. So, a colleague I work with, Stephen. So to summarize, definite advantages in construction using computer vision. Hopefully you're starting to see some of that. Safety, security, compliance, that real-time optimization are some of those insights that can be built up over time. Vision's one area. I talked to somebody earlier on today about this. You can start to combine vision with other devices, such as IoT sensors, start building that picture up. Think of cameras just as another sensor. And finally, I reiterate, responsible AI, hugely important. It's not about snooping on people. It's about their helping them, providing insights to help people do their job. Humans have to remain in control. And with that, thank you all for your time. I think there's questions in the... Perfect. Thank you.